In the last class we had seen what is elasticity, what is plasticity, and we have very well understood the two important the physical values or the physical quantities, that is stress and strain. We had defined stress as the restoring force per unit area, and for the strain we had the change in configuration. It can be in size, shape, length, volume, whatever it is, divided by its original configuration. Okay, so we dealt with all these things in the last class, but in today's class we will be doing with the different types of modulus of elasticity. And let us understand what is the coefficient of elasticity. In order to understand all these things, we need to know one very important law, what we call is the Hooke's law. Hooke's law. Now, what is Hooke's law? According to Hooke's, one of the scientists, it states that within the elastic limit, you have got stress is proportional to strain. Okay, or stress by strain is equals to constant. Now this constant is known as coefficient of elasticity. We call this as coefficient of elasticity. Very simple. Within the elastic limit, we have got the stress as proportional to strain. That is, stress by strain is equals to constant, and we call this constant as coefficient of elasticity. Now suppose if you are plotting a graph, let us assume this is strain and this is the stress. You will see that strain by stress is equals to constant, or stress is equals to constant, and this is multiplied by strain, right? So when we have this stress is equals to constant multiplied with strain, then what we really need to get, that here if you compare it with the formula y is equals to mx, okay, so this m is the coefficient of elasticity, that is the slope, and you get a straight line. You get a straight line passing through the origin. So if you get to know the slope of the graph from the graph of the stress and strain, you can easily find out the coefficient of elasticity. Okay, that is one thing. Now let us do more about the different types of the coefficient of elasticity. We are dealing with the different types of coefficient of elasticity. First one is Young's modulus. There are three different types. Second one is bulk modulus, and the third one is coefficient of rigidity. So what we have within the elastic limit, the stress is directly proportional to strain, that is, stress by strain is equals to constant, and what we have, this constant known as the coefficient of elasticity. Now if you plot a graph between a stress and strain, you will find that you are getting a straight line because it is directly proportional. And if you compare it with the equation of a straight line, y is equals to mx, so y, here the m is played by the constant, and that is what we have, the coefficient of elasticity. So you can easily get the from the slope of the graph, you can find out the coefficient of elasticity. Now we have got three different types of elasticity: Young's modulus of elasticity, bulk modulus of elasticity, coefficient of rigidity. Now in today's class we will be just discussing about only one type, that is the Young's modulus of elasticity. Let us discuss about Young's modulus of elasticity. What we have? Young's modulus of elasticity. We just denote it by capital Y. Now if you look at your formula, then this is equals to tensile strain by longitudinal strain. It means we are dealing with what? The length. Suppose if you take a wire, this is your wire and this is the weight. Let us assume 3 kg weight is the weight. So here this is the force, the deforming force. Let us assume the whole length we have taken it as L. Okay, so this is what is equals to mg. Weight is representing what? Mg, the weight, and that is actually the force. Okay, so if we go by definition, y is equals to force by area, and this is, let us assume it has been extended up to this part. L is the extension. L is the extension of the length. So it is L divided by capital L. So F is that restoring force, A is the area. So F can be mg. A is equals to pi r square. Why? Because A is equals to area of cross section. If you take this wire, cut it, you will find that the part you are getting, it is circular, right? So what we call it is area of cross section. Okay, so this is pi r square, this is mg, and now what we need to do, we need to substitute. This is small l by capital L. You can easily find out mg by pi r square, right? Mg by pi r square, and this small l, and this is capital L. So you are getting the Young's modulus, and its unit is Newton per meter square, because the strain has got no unit and the upper part is given its unit. I hope you have understood this. Thank you.